All right, you are looking at Unit 9 review, and this was a chapter where, I did see some good success in it. I saw some shortcomings, and I think they really did stem from previous chapters. Some of it was a little bit, maybe we just didn't know what a prism meant and whatever else. And there were a lot of formulas and such. None were to be memorized, but now with the cheat sheet, you're going to have some. So we're going to look at all of these. I feel like, and like I do often, I want to skip down and look at one thing first, and that is volume, before I talk about any of this. So let me first go down to volume and define this for you. And it'll be pretty straightforward. The fill of an object. So basically, like example, how much water, sand it takes to fill up something. And the reason why I say that is because water is so, loose. Water can fit in anything, whereas like puzzle pieces and gumballs and stuff, they leave open space. Water and sand don't really, and you can really tell how much something is when you fill it up. Those are measured in cubic units, and so as I go back up to the top, we're going to go ahead and look at that as we go. So let's go ahead and define all these. A polyhedron. Now, this isn't something that we actually really talked about too much, polyhedron. We didn't use the term too much, but that's kind of the three-dimensional shape. So polyhedron means many faces. It's kind of the Latin for it. And it is the, it's this, it's this thing over here. It is a 3D shape with polygonal faces. So that's one thing. So everything that has a sort of side is a polygon. And as we know, a polygon has sides and angles. And it's an enclosed shape with sides and angles. So these are all polygons. Okay. Now these things right here, and we don't really mention them ever, but these are called edges. All these right here. They're called sides in a 2D shape. Like this pentagon has 5 sides. In a 3D shape, we're calling these edges. And in the corners where the edges meet, these are called vertices. So this is just one type of polygon. So for instance, a sphere is not a polyhedron because a sphere just has one kind of bald face all around. And not all polygons. A cylinder, same thing. A cylinder, although you can unfold the lateral facing to make a rectangle, the bases are circles, and circles are not polygons. So this, for example, is a polyhedron, a prism. Excuse me. And a pyramid is a polyhedron, but a cone is not a polyhedron for the same reason. So I don't really know if there's anything else I want to define for polyhedron. Okay, prism. Okay, let's see if you can remember this. So, it's a polyhedron with congruent parallel bases. So, that's saying enough kind of right there. When you say that, it kind of implies everything else about it, but I will write the rest of it as I go here. In fact, I need to fit all this. I'm going to zoom out. Shrink it a little bit more. Its lateral faces are rectangles. I think that's all I kind of want to write for prism there. So what we're looking at here for this prism, a polyhedron, meaning it's a 3D shape with polygonal faces. So everything here is going to be a polygon, including the top and bottom. So bases can be hexagons, they can be rectangles, they can be triangles, whatever they are, but that's the top and bottom. Those guys are called bases there. Okay. And then the sides are the lateral faces, if you remember those. These are all going to be rectangles right here. When you unfold them or when you look at them, they're all rectangles. And the reason that is because you have 2 bases on top and bottom. That makes they're congruent bases. That makes these part congruent. And then because they have sides and go straight down here, that's what you're going to make. You're going to make rectangles. Whereas you can look at this polyhedron, or this polyhedron here, top and bottom don't necessarily create rectangles here, but in prism they do. So also in a prism, the volume of a prism is found by V equals capital B times H. So that is volume equals area of base times height. Okay. So this is huge because you need to know what the area of each base is. This isn't just for volume, it's also going to be for cylinder, or for prism, it's also going to be for cylinder. If you have a hexagon, the area of your base is 1/2 apothem times perimeter, so you need to find the apothem and perimeter when you do it. When it's a triangle, the area of your triangle is 1/2 base times height. When it's a square, it's side squared, etc. So your base changes every single time. So you need to make sure that you know when you find the area of the base, you're doing it that way, and we'll do some practice problems with that. Okay. A cylinder is like a prism, but with circular bases. So everything else about a cylinder is the exact same as a prism, only the bases are circular. So you can call it a circular prism, although by definition a prism is a polyhedron, and by definition a polyhedron has faces with edges and vertices and polygons and everything, and circles are not polygons. So that kind of defies that idea. So it's like a prism. It's not exactly. So same thing. The volume of a cylinder is also found by volume equals area of base times height. Now in this case, your area of your base is the area of a circle. So I'm going to put area of circle times height. So what's the area of a circle? The area of a circle is pi r squared. So I'm going to put pi times r. I don't know how to do squared. Is it? I think it's this. There we go. Pi r squared. So that's area of circle times height. So notice that. Or area of base times, yeah, area of your circle. So the area of base is area of a circle, pi r squared, multiplied by height. You'll get the fill of your entire object there. Okay, a pyramid is it's a polyhedron because it has many faces. It's a polyhedron with one base. Lateral faces meet at point or tip, whichever way you want to put it, or at the top or whatever else. So here you have one base right down there. And then you have these guys all going up and meeting at this crown right there. So your lateral faces, by the way, here, I need to do more. Lateral faces, which are triangles instead of rectangles, meet at point or tip. Also, finding the volume of it. And you know what? Wait, I haven't talked about surface area. I might have to do all that. I might have to include all these. I'm sorry. I'll have to go back for these. But volume of pyramid is found by is 1/3. I'll just put this 1/3 the volume of prism. So your volume is 1/3 of area of base times height. So what's interesting with this here, though, is that you need to go ahead and find your height as you do this. So I'm looking at this example right here with this pyramid. My height is not the height of my triangle, this slanted one down here. No, no, no. It goes straight down the middle. And it's perpendicular right there to your base. So there's your height. So you're going to have to find that in a certain way, or they'll give it to you. It doesn't matter. But you find that one, multiply by it. So the whole relationship here is that if you have a pyramid and you have a prism that are the exact same, these ones aren't, but if you fit a box prism around this thing, the pyramid is exactly 1/3 the volume of that pyramid right there, of the volume of the prism right there. So that's kind of how that relationship works. Okay, cone. Cone's kind of like the pyramid in the same way. It's like a cylinder, well, cylindrical, let's see, like a pyramid, but with circular bottom, with circular base. So just like cylinder, it's like a prism. A cone is like a pyramid, but with a circular base. So there's your cone example over there. It looks just like this pyramid, only has a circular base, and pyramid's a polyhedron. This one is not. So again, like one, but not one. Volume is the same. Volume of cone is 1/3 the volume of, this time, volume of cylinder. So your volume equals 1/3 of, remember, volume of a cone is, a cylinder, it's always going to be pi r squared times height because your base is a circle. So I can do 1/3 pi times r squared times height. Like that. Okay. We'll do practice with these. A sphere, I don't know if we're going to run into a sphere, but I might as well put it. Sphere, think like basketball, baseball, etc. I'm just going to put examples, and then I'll put your formulas for volume and surface area. Basketball, baseball, ball. I'm going to emphasize baseball when we talk about surface area, because it specifically looks like a baseball when we unravel in a certain way. Has a radius, / diameter. So same way, it crosses through the center, or it hits through the center. Radius is the same way every which way around. It's a 3D circle. I'll put that at the top. You can put it wherever you want. I'll put 3D circle, like those. The formula for the volume of a sphere, it's kind of weird. So I'll just put it, volume, it's 4/3 pi times r cubed. Okay? And I'll put the surface area here as well at some point. But that's looking at volume first. Okay? Okay. Now match up the appropriate... Okay, so now we're going to look at surface area here. So surface area is flattening the object into 2D, and then taking the area of the outside. Think wrapping paper. So think of how much wrapping paper you need to wrap a present if you didn't have to fold over anything else more than once, how much that takes. So we've done nets before for all but the sphere. And I'm going to look at each one and see if you can notice what it is. Remember the unraveling of these things. This one's going to be the cylinder. I unravel the cylinder right here. The lateral faces go outward, like so. And then you can fold the circle on top and the circle on bottom, and boom, right there you have your cylinder right here. Okay, the next one, look at my lateral faces. They all went downward. If I folded them back upward, up all into here, you'll notice those triangles all meet at one general location. That's going to be where this pyramid is right here. So if I look at this pyramid, and I folded these triangles downward, flat onto the ground, that's what we're looking at there. Okay, so this one's a pyramid. Okay, this is the one that's the sphere. Now, what this is, and I don't know if you've seen a baseball before, but go and find a baseball or go Google image it. You'll see that it has the stitching around it, and if you follow what the stitching does, it goes around these parts right here, but when I hook it together with this part right there, these parts line up. Like this will match up here, 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 etc., like that. Not that that's what it looks like, but when you fold them together, that's what it all looks like. Those are the parts that match up, and it becomes the sphere right there. So that one's a sphere. Okay, this one is actually almost exactly this one because they're both hexagonal prisms, but you'll see that the top and bottom are hexagons, and they meet up in certain parts here. These rectangles are the lateral faces. They all fold together. Like these would all come inward with these guys and meet up, and this would fold down, and this would fold up, and you'd have that hexagonal prism. So this is an example of a prism. And I'm looking at everything that's not polyhedron because I don't want to give you one there. This one's the cone. If you can see the cone right here, this is the party hat top that unravels and becomes that. This circular base folds outward and it's left out here. So this one is the cone. And okay, looking at surface area here, I'm going to save the time for explanation. But you can always find surface area of something by taking the area of each individual thing. Like I could take the area of this rectangle if I knew this length and this height. I could take the area of one of these circles if I knew the radius, and I could find the other one the same way. But the surface area of a cylinder, in general, it is let's see, 2 pi r times height plus 2 pi r squared. And I'll explain what those parts are, or where they exist on this thing. I said I wouldn't, but apparently I'm going to. Okay, I'll do 2 pi r squared first. 2 pi r squared is saying pi r squared for the area of this circle, pi r squared for the area of this circle. You add those together, you'll get 2 pi r squared. So that's this part right here. This part, remember that the unraveling of my cylinder right here, all that stuff, all unraveled and all around it, I guess I'm just drawing all around the whole thing. But this lateral facing right here, this part's your height, this green. This part right here is the circumference of your circle, so that's 2 pi r. When this whole thing unravels, that becomes the width of your cylinder right here. So this is 2 pi r, and this right here is your height. So that's 2 pi r times height, which goes right there. Okay? Pyramid. Surface area of a pyramid is kind of different, and this one, again, I can't take too much time to explain here. But I'm going to say surface area is 1/2 perimeter of your base. Oh, here, I'll write base after. Perimeter of your base times slant height. That's an L. I just said slant height to you, so make sure you write that down. So your slant height, let me mark that for you, is the one that it comes right here. It's from your triangle and it goes upward right into there. That's that L, your slant height. And you can see it right here. Boom, right there, slant height. This is your height straight up and down from the tip. This is your slant height. It goes diagonally across on the triangle. So that's something that you could find as well through different measures. Again, we're going to practice it. Sphere, it's pretty much this simple. These aren't exact circles, but they are approximately circles, and they fill up about the same area as like a circle like right there. So if I put a circle here with the circle right here, not quite, but you know, if I put 2 circles there, those are about 2 circles right there, and then 2 circles right here and here. The surface area of the sphere right here is 4 circles, so the area of 4 circles, it is 4 pi r squared. 4 times pi times r squared. Okay. Surface area of a prism is, so just like the cylinder over here, remember when we unfolded this, this was unfolding this portion, the circumference of my circle. Now when I take a prism and unfold my rectangles, I'm looking at the perimeter of my base as this length all across here. So this is the perimeter of my base. This is still my height. So the perimeter of my base, here we go, let's do surface area equals perimeter of base times height. Whoops. Plus, so perimeter of your base times your height's your lateral area. It's the area, it's right here. I should have just put that. Your lateral area is your perimeter of your base times your height. And then then you need the areas of your two bases, like the area of this hexagon and the area of this hexagon. Add it all together, you get the surface area of the whole thing. So I'm going to put LA equals P base times height. Okay. That's probably better for me to write. Sorry that I'm roughing around all this. This is my first go at this. In the cone, I'm actually not going to be able to explain it all, at least why it comes to be. It comes with setting up proportions. But take a look at this cone. Oops, I'm sorry. Take a look at this cone right here. And this portion, the circular base, it has a radius of r. Okay, you can't really see the r, but that's this guy right here, r. So finding that part, it's just going to be pi r squared. This, you have a slant height in a cone as well. So this guy going down to any leg, or to any portion, that's called your slant height, L. So that's this part right here, goes down, that's called L. This is a fraction of your circle right here, some central angle. Again, that's the part I can't talk about. This part right here is the circumference of your circle. So this rim all around that I just drew in red, that's the circumference of your circle. So that is 2 pi r. So the whole thing, if you set up the proportion and do it right, you're going to end up getting a surface area of pi times r times L. Remember we spelled pearl with it, plus pi times r squared. Times squared, but squared. Okay. So those are my 5 surface areas that I'm conscious of, or trying to keep track of. Okay, and the final thing I want to talk about, ratio of side, length, perimeter, etc. Here's what I'm going to do for you. I'm going to draw an object, like a cube. And we're going to grow it by some amount, and then we're going to compare these two things. Okay, I drew a little cube, and what I'm going to do is duplicate it and make a bigger one. Now I'm going to make it twice as big, or at least try to. So I'm going to grow this thing. I guess I have to do it this way. Grow this thing so much so that any side length becomes twice as big as the other. This is about where I need to be. So if you think about it, see this guy right here. In fact, let's make him a different color. Whoa, didn't want to do that. I might want to do that later, actually. To make him a different color here. Look at this side down here. It takes 1, 2 of these to fill up this other one. 1, 2. Okay. So, for example, you might have a ratio of sides of 1 to 2 here, but I'm going to say r. R is a fraction of a over b. If I have a side length of a here and a side length of b here, my ratio here of side length is a over b, like 1 to 2, for instance. So let's example r equals 1 to 2. Okay. Now, here's the thing with the cube. Because it's a cube, I'm going to say this length is also a, so this length is also b. Doesn't matter. The thing that has to exist here is that these objects have to be similar. They have to grow by the same amount each direction. It doesn't matter if these are the same thing, but if this is twice as much over here, this has to be twice as much over here. Okay, ratio of area. Let's say I just want to look at the facing here of that square. And so I will fill it, that color right there, green. So look at the green right here in comparison to the white of this cube. I want to say how many green squares does it take to fill this first square right here? It takes 1, 2, 3, 4. Right, so now we're looking at a ratio of area here of 1 to 4. I'm going to look at the example first. R squared is 1 to 4. So ratio of area is r squared. What you do is you take this value and you square it. So r squared is a squared over b squared. You take 1 and you square it. and you take 2 and you square it, or whatever your ratio of sides was, your original r value. Ratio of volume, r cubed, I guess I'll write this one up top first. It's a cubed over b cubed. Okay? And go and take this again. Let's see if I can unfill it. That'll work. Okay, what this question says is, how many cubes can I fit into this other cube? So what I need to do really is I need to make these things I need to make a little bit more out of this right here. So if you can imagine that's the back. Actually, let's do dotted lines. If you can imagine this is the back right here of this guy. And I need to make the back of this guy as well. Like so. Okay. Go and group these together. Okay, it says how many of these can I fit into this whole thing? So I'll go 1, 2, 3, 4. That's the bottom. Moving up to the top. 5, 6, 7, and 8. So it takes 8 of these cubes to fit inside this one cube. And that stays consistent with this formula here. R cubed will be 1 cubed over 2 cubed, which is 1 over 8. So the ratio here of volume is 1 to 8. It takes 8 of these cubes to fit in these. So you'll see that the ratio grows as you move up. It doesn't stay the same. Okay, I'm going to do some problems with you now. Okay, the surface area of a sphere with a radius of 6 is 288 pi square centimeters. So this is where it's like, okay, I didn't ever practice this before, but I do know the formula now. Surface area of a sphere is 4 pi r squared. So I'm going to write that first. Four pi r squared. Now it says the surface area of the sphere is 288 pi. So it's 288 pi equal to 4 pi times 6 squared, because 6 is your radius here. 6 squared is 36. 36 times 4, you'll get 144. So 144 pi equals 288 pi? No, that is false. It's half as much, but it does not equal it. Okay, part B. A prism and a pyramid have the same base area and the same height. If the volume of the prism is 240 cubic centimeters and the volume of the pyramid is 80 cubic centimeters. So there's some work you have to do, and I think it really does help with the picture. If I go ahead and draw do a parallelogram to make this work. If I draw a pyramid like so, okay, and then I draw a prism with the same base, remember, so this prism won't look any different at the base. But I obviously have to draw upward this time. It has the same height. Now, you might be looking at this and go, dude, you just drew it at a different height. No, it's at the same height, just this one's more in the foreground. Because remember, that point is up in the middle of everything. So here's my... I could draw this better. Here's my prism that goes around it. Okay. And again, the bottom's the same. It's just a different color. I'll go ahead and stick with that color and draw with it, though, and see if you can just get an example of what we have there. So prism and pyramid. Same area of the base, same height. Okay. The volume of the prism is 240 cubic centimeters. And it says the volume of the pyramid. Now, I'm just going to go ahead and go with volume of pyramid. It's 1/3 the volume of the prism. We already know that. We said it before. Volume of a pyramid is exactly 1/3 the volume of a prism. So it's 1/3. I could have just put V prism here, but if you know the area, base, and height, you can do it. Here I don't know the area, the base, and the height, but I do know the volume of the prism, and the volume of the prism is 240. So take 1/3 of that. That will be 80 cubic centimeters. That's what that asks you. And yes, that's true. I didn't have to draw this. I just wanted to give you a second re-envisioning and say, okay, I know what I'm looking at here. Okay, if each edge of a cube is 4 inches, then its surface area is 96 square inches. So again, these are kind of hard questions because we're using new terminology here. This is where we saw edge. Edges are these guys going around it right here in polyhedrons. All of those, even in the pyramid, those are edges. All these guys right here. So a cube, by definition, has all congruent edges, just like a square has all congruent sides. A cube is made up of nothing but squares. So, checking out this square right here, or this cube, a rough estimate of the cube, it says here, each edge of the cube is 4 inches, so everything around it is 4. This is 4, 4, 4, 4, 4, 4, etc. All these are 4. Now, surface area is unfolding this cube. So, a cube unfolded would look like this rectangle right here, made up of 4 squares. It's not going to be perfect at all. But I have 1, 2, 3, 4 squares. There's a square base on top and a square base on bottom. Now, everything here is 4. I'm going to practice with the lateral area, the surface area formula, though. So my surface area here equals lateral area plus the area of both of my bases. So area of my bases, that's 4 times 4. That's 16. This is 16. In fact, I could just say all these are 16, add them up, and that's probably the easier way to do it. But for the sake of practice of what we're going to do also, I want you to keep this in mind here. If these are all 4 this way, then this whole length is 16. This height here is 4. So your lateral area is 16 times 4, which is 64. And your 2 bases are 16 times 2, which is 32. So 64 plus 32 is 96, which is what we asked for over here, and that is true. Okay, multiple choice. Circle the correct answer. You must justify each of your answers. The heights of 2 similar cylinders are in a 1:4 ratio. What is the ratio of their surface areas? So if I have 2 similar cylinders, what you're looking at here is like, hang on. I got a cylinder right here. Its height is x. I don't know what the height actually is. I have a cylinder here. It's similar to it in every way. Obviously, I didn't draw it to scale probably. But this height is 4x. Okay? They are not asking you to find out what the height is. They're not asking you to find out what the surface area is or anything else. But the height is a length. And the ratio here, it's just A over B. Excuse me. And that is 1:4. Your ratio of area, or your ratio of surface area is ratio of area. So ratio of areas are squared. That's A squared over B squared, which is 1 squared over 4 squared. That is 1/16. So it's going to be C. Okay, how many surfaces does a regular octagonal pyramid have? Something I guess I didn't talk about when I talked about pyramids and prisms and such. They are named by their base. So this is a hexagonal prism because its base is a hexagon. This is a square or rectangular this is a square pyramid or rectangular pyramid because it's named by the fact that its base is a square or rectangle. Okay? An octagonal prism pyramid is a pyramid with 8 well, that didn't really work, but with 8 sides on the base, 8 edges there. And they all meet up at the top right there. Excuse me. Oh. So the number of faces is, there are 8 triangles all around here. It's not very well drawn, but there are 8 triangles, and then there's 1 base. So you're looking at a 9-faced shape. That's how many surfaces is faces. 9 surfaces there. The base plus the 8 triangles. Okay, what is the surface area of the solid below? Assume there are no hidden blocks. So I'm looking at, now this one's kind of tough to do. What I've kind of preached in practice is say, okay, you don't know where there are no hidden blocks, so count the number of faces that you can see in each direction. I'm going to first look at the front. I'll look at front, right, left, which can't be seen, back, which can't be seen, top, and then bottom, because I already wrote back on the right B. B right there, right bottom right here. Excuse me again. Okay, the front. I got 1, 2, 3, 4 faces. On the right, I have 1, 2, 3, 4 faces. Okay, the left is hard to see, but it's like these guys right here. This one. Now there's one down here as well, because remember, there's nothing there. So 1, 2, 3, 4. There are 4 left faces. On the back is over here. It's 1. Well, it says assume there are no hidden blocks, but that doesn't. But you can assume that there's one underneath this guy here. That's tough to say to you guys, but yes, you can make an assumption that there's one right down there. So there's 1, 2 back there, 3. 1, 2, 3 in the back, and 4 right back there. Okay, so all these seem to have 4. Jeez. Okay, the top has 1, 2, 3, 4, 5, 6. And the bottom has the same amount, 1. If you think about the bottom being over here. 1, 2, 3, 4, 5, and 6 down here. There's your bottom. So 4 plus 4 plus 4 plus 4, that's 16, plus 6 is 22, plus 6 is 28. So 28 square units. Remember, surface area here is just the area of these individual cubes. I guess these are all 1 cubic unit. Cube surface equals 1 cubic unit, or square unit, I'm sorry. Square unit, you multiply that by the number of faces there are. That's 28. Okay, find the area of the regular pentagon below. Show all work. Round your answer to 2 decimal places. Now, this is something from a previous chapter, but this is like a 2 or 3 part problem. Like this part will help you easily find this other one over here. So let's get to work. Make sure we can practice this a little bit. What I'm going to do to find the area, I need the apothem. A right here. This is a right angle, and this is constructed with a right triangle over here. So it would help if this length here is 6, because it's half of 12. I need my apothem. I need my perimeter, which is easier to find. That's 12 times 5. Which is 60 centimeters. I'm on a yawn fest. I don't know why. I'm very tired. I remember, this is half of the measure of one central angle. If this is the entire central angle right here, the central angle is 360 over 5, which is 72. 72 degrees. So half of that, half of it, not a third of it, equals 36 degrees. So this part right here is 36. I have this length 6, which is opposite 36. I need to find A, which is adjacent to 36. So I'm going to use the tangent function in SOHCAHTOA. Tangent of 36 equals 6 over A. So A equals 6 over tangent of 36. Notice how I'm going more quickly through this kind of problem. I need to assume that you know this stuff now if you practice this. So your apothem is tangent, 6 times tangent of 36. I can round off that value. I'll do a practice with it. 6 divided by tangent of 36, you get 8.26 about. So your area is 1/2 your apothem times perimeter. So it's 1/2 6 over tangent of 36 times perimeter, which is 60. So I can do that times 60 divided by 2. So I can get 247.75 square centimeters. Okay, so that's the area of that whole regular pentagon right there. And it said round to 2 decimal places. Okay, find the volume of each regular pentagonal prism below. Round your answer to 2 decimal places. Okay, this one's going to be pretty interesting here. I can do a couple things. I'll show you what. First of all, this is a rectangular pentagonal prism, regular pentagon. We saw this up here. Like this regular pentagon had edge lengths or side lengths of 12, this also has edge lengths of 12. So all these are 12 up here if you look at that. So instead of finding the area of the pentagon again, remember the volume here is area of base times height. The area of my base I already found just up here. Area of my base is 274.75 square centimeters. Okay. My height is 10. They give you that. So volume is 274.75 times 10, which is 2,747.5 cubic centimeters. So that is for this guy right here. Okay. Now this one's interesting because it's different lengths. And I'm not going to ask you to redo all this again with length of 24. You can do this in one of two ways. You can say, I know what the area... Gosh, I'm already out of this. I am so sorry. I know that the area of my pentagon earlier here, the base, was 247.75. I know that my edge lengths are twice as much. Now, that means that the ratio of areas, it's not 1 to 2. If my ratio of sides is 1 to 2, my ratio of areas is 1 to 2 squared. 1 squared to 2 squared, which is 1 to 4. So I can multiply this area over here by 4, and then multiply it by this height. Or better yet, I know ratio of volumes is 1 cubed to 2 cubed, so that's 1 to 8. So my volume of this guy is going to be 8 times as much as the volume of this guy. So if this guy is 2,747.5, my volume of this other guy is going to be that number. Times 8, because this one's 8 times as big in terms of volume. So that number equals 1,900... I'm sorry, that's not right. I forgot to multiply by 10. 19,800 and about 20. I'm just going to leave it at that. Cubic centimeters. It's kind of rounded off there. I should have given you a better number. I think 0.90, but that's okay. Okay, find the surface. Oh gosh, find the surface area of the regular pentagonal pyramid below. So again, that means there's a pentagon as its base. And look at this. This is that regular pentagon with side lengths of 12 all around. So again, the area of your base is going to be 247.75. So that's where they save you with this problem. They make you do this first. They say, we'll simplify it for you. Do something you know how to do instead of overcomplicating it and make it all as one. As long as you can recognize that relationship, you're going to be in very clear state there. 18 is your slant height. So I have area of base is 247.75 square centimeters. Your slant height is 18. And we also need the perimeter of the base, which was 60. We did that up top as well, right up there. Okay, because the volume of a pyramid, I'm sorry, not the volume, the surface area of a pyramid. Oh, you know what? I skipped something. Oh gosh, that's bad. I have to go back. It's not just 1/2 perimeter times where is it? 1/2 perimeter base times slant height. It's also plus the area of the base. So it's not just enough to have those 4 triangles. You also need the area of the base there. So 1/2 PL times B plus B. So your surface area is your lateral area. 1/2 perimeter times slant height plus the area of the base. We have all these numbers over here. 1/2 60 times 18 plus 247.75. So let's see what we get. I get 787.75 square centimeters. Okay, so that was the surface area. They underline it for you. Okay, find the area and circumference of a circle with diameter of 10. Show will work, leave pi in your answer. So if you don't know what it's asking, try and draw it out. I got a circle. It's got a diameter. Its diameter is 10 centimeters long. What we need for area of circle, we need circumference too. Circumference is 2, well, it's 2 pi r, but it's also diameter times pi. Because I have the diameter, I'll just use that. So circumference is 10 times pi. That's it. Well, centimeters. Your area is pi times radius squared. Your radius here is 10 over 2, which is 5. It's half the diameter. So that's pi times 5 squared, which is 25 pi square centimeters. Okay, so like I said, radius is 5. Make sure you know how to do that. Okay, find the volume and surface area of the cylinder below. Show all work, leave pi in your answers. Okay, even though this thing is laid down sideways, you try and draw it upward or something, because you have to know that your height is 20. Your height is the lateral facing right here. This is your base, just like this other circle is your base. You have 2 bases there. Now you have a radius of 10, or a diameter of 10. So again, your radius is 5. So that'll help for some things. Let's do volume first. Your volume is pi r squared times height, area of base times height. So volume is pi times 5 squared times 20 for your height. 5 squared is 25. 25 times 20, what was that, 500. So that's 500 pi. They say leave it in terms of pi. So that's 500 pi cubic, is it cubic centimeters? Oh, inches. Cubic inches. Okay. Surface area, you'll have to look back at your formula if you don't remember it. It's hard to remember. It's the area of your 2 bases, 2 pi r squared, plus the lateral area here, which is, this is your 2 pi r circumference, 2 pi r times your height right there, height. 2 pi r h plus 2 pi r squared. So that is 2 pi r, well, r is 5 squared plus 2 pi times 5 times height of 20. So that's 50 pi plus 200 pi, which is 250 pi square inches. I know my handwriting's been sloppy here. I'm kind of trying to rush through some things. Last page. Carefully look at the triangular prism shown to the right. Find the missing side and area of the triangular base. Show all work. So you don't even have to find the whole volume. We just need the area of the base. Well, we will have to, it looks like. This is part A. So what we're looking at here is a right triangle. And if I redraw you a right triangle here, it won't be drawn to scale. But I have a right triangle here with side lengths 5 and 12. You can use Pythagorean theorem. But if you know this is a special triangle where C will be 13, you do the math yourself, though, you'll get C equals 13. So that's this one right here. Okay, find the area of the triangular base. Now remember, your height is, here's your base, 12 or 5, doesn't matter. Your height is perpendicular to that. So we're going to do area of a triangle is 1/2 base times height. So area is 1/2 12 times 5, which is 1/2 of 60. Which is 30. That's an area, so it's squared. Okay, draw and label each of the 5 surfaces that make up the prism. Add the surface. So that basically means draw a net. So I'm going to draw this net for you right here. I'll start off with that rectangle here that'll make up these 3 side lengths. So if you remember looking back at this, this is 13. I'm going to be drawing a net where I have one rectangle that has length of 5. This height's always going to be 16. Another rectangle right here with a length of 12, and this length is 16 all the way around that height. And then this last one is 13. So here's the 13 side right here. There's that rectangle. Here's the rectangle with 5 and 16. Here's the rectangle 12 and 16. The other thing you need to be careful of and very conscious of is where you draw your top and bottom. You can draw them wherever, but they probably want to look good with what you're doing. When I draw this here, I want to match up side lengths together. So for instance, this needs to be 5, because when it closes up and folds in, it matches with that 5 right there. So this needs to be 13 drawn on that side, and this is my right angle. And I can fold this one over here the same way, just like that, where I have 5 and 13 with this 12. Find the surface area of the triangular prism show all work. So my surface area is lateral area plus 2 area of both your bases. We have area of one base is 30, so 2b is 60. Your lateral area is your perimeter of your base, 5 plus 12 plus 13, times height, which is 16. So lateral area is 17 plus, so 30 times 16, which is, I think, 480. So your surface area is 480 plus 60, which is 540 centimeters squared, square centimeters. Okay, find the volume of a triangular pyramid with the same base and height as the triangular prism show all work. So make sure you read that very carefully. So what I'm trying to find here is if I have a triangular pyramid within here, so it goes like up like that and down like that and in like that. Here's the look of the triangular pyramid. Okay, now this one is actually you know what? I'm looking at this and I'm trying to decide if that's exactly what... Oh, wait, did they give us a... Oh, no, okay, never mind. Oh, we already have the height. I was going to say, this is going to be difficult because we need to find the height, but we have the height, which is 16. So, your volume... So the volume of the triangular pyramid, or of prism, first, is area of base times height. Area of base is 30, and height is 16. So your, wow, so the perimeter, I was looking at that, your perimeter, your area are the same thing. So that's area of base times height, which is 480 cubic centimeters. Okay. The volume of the pyramid, the triangular pyramid with the same stuff would be 1/3 of that. It'd be 1/3 the volume of prism. So that's 1/3 of 480, which is 160 cubic centimeters. Okay, last problem to go. Carefully look. Nope, 2 more problems. Carefully look at the cone shown to the right. Find the slant height of the cone. Show all work. Okay, this altitude is your height. Remember, your slant height's over here. This is, again, this is a right triangle that you're looking at. If you looked at it in 2D, this cross section here. This is, again, a 5, 12, 13 special right triangle. So your slant height is 13. If I wanted to show more work, I'd say 5 squared plus 12 squared equals L squared and do the rest of the work there. Find the surface area of the cone. Show all work. Okay, you'd have to look back at your other sheet if you don't remember it. Let's see if I remember it. It's going to be the area of your base for sure, plus pi RL. Pi times radius of circle times slant height of cone. So your R is 5, slant height is 13, so plug them in, get to work. Surface area is pi times 5 squared plus pi times 5 times 13. That equals 25 pi plus 5 times 13, 65 pi. So that equals 90 pi, which is about, plus 25 times pi. It's about 282.74 inches, square inches. Okay, find the volume of the cone. Show all work. Volume of cone is 1/3 area of base times height. Okay, your area of base is 25 pi. We just wrote that before. Your height is 12. So volume is 1/3, 25 pi times 12. So 25 times 12 divided by 3 is 100. So I'm going to get volume is 100 pi, or about 314.16 cubic inches. Okay. Okay, find the surface area of the pencil below. Show all work. Hint, use answers to problems 6 and 8. So what's kind of nice here, check this out. Problem number 6, oh, that's way back there. Problem number 6 had a cylinder base there. So that's going to help you, or a cylinder shape. So that's going to help you right here rough out and find some of the stuff, because they're assuming this whole thing. I know there are lines here, but this represents a circle. You can see right here, this is a circle, and this is a cone. So this is not a 1, 2, 3, 4, 5, 6. 1, 2, 3. It's not a hexagonal prism. It is a cylinder. It's a cylinder with height of 20 and radius of 5. So we are looking at this guy right here, height of 20, radius of 5. So that pencil neck portion will have the same surface area as the surface area we found over here. So going back one more time, the surface area of this was 250 pi. So this portion right in here, well, not in here, but the surface area right there is 250 pi. Okay. The pencil portion is also the same as the cone that we had over here. It has a radius of 5 and a height of 12. So you'll see this here, radius of 5, as you can see here on this side 5, on this side 5, and a height of 12. So we want to find the surface area of that. Oh wait, we already found it. Right here, surface area of the cone is 90 pi. So this guy here is 90 pi. Finally, we got to do some work right here as we go along. This has a height of 3 and a radius of 5, so surface area of that portion right there is you know what? There are some things that I'm going to have to take out of this problem, and I'll explain why in a second. But the surface area of the entire cylinder is 2 pi r squared plus 2 pi r h. Your h in this case is going to be 3. So your surface area is 2 pi times 5 squared plus 2 pi times 5 times height, which is 3. Surface area is 50 pi plus 15 times 3 is 30 pi, which is 80 pi. So your surface area of this whole thing, now this won't be the correct answer, and I'll tell you why. But your surface area, if you add all these up, of the whole pencil is 90 pi plus 280 pi plus 80 pi, which is 350 pi, 450 pi. Square centimeters. Now the reason why this answer is not correct, or not yet, this is a good jump start, but we have to do 2 more things. Remember when we did the cubes? We had these cubes right here, and there were some parts we didn't account for. Okay, if I'm looking at the right shapes, am I counting this face right here inside that cube? No, I'm not, because this thing obstructs it. If you think about cubes, we're just talking about the surface. This part, this part, this part, etc. All those, not the ones that are blocked out of the way. Not saying ones we can't see, but the ones that are actually blocked from being a part of the surface. On the back, there are things on the back, like back here and stuff, that are on the surface of this object, but we don't want to account for them when we do it. So when we look at this example right here, going down, this circle right here is actually not a part of what is visible and accounted for. Take a look at a pencil. You can't see that circular portion right there. It's being covered by this part and then this part right there. So this circle we have to subtract out. And this circle is also something else that we have to subtract out because it's not a part of the pencil which we can see. Okay, I hope that makes sense when I say that. These parts are obstructed. That's not a part of your surface. So I'm going to take 450 pi and subtract 2 of my circle areas right there. This is 25 pi. This is 25 pi. So I can subtract 2 times 25 pi. So that's 450 pi minus 50 pi, which is 400 pi square centimeters. Now, I could have done that originally if I wanted to, you know. I could have not added them in the beginning, but because we're working with formulas and such, and you don't want to screw yourself up, you don't know what counts for what, just make sure that you get back in the end, you look at the drawing and say, did I do everything correctly as I needed to? So 400 pi is about 1,256.63 square centimeters. Either or, unless it said round. Okay, so that's all the work there. And again, I do apologize. I think that there were parts where I kind of came into this own thing unprepared, and I had a lackadaisical effort, kind of poor handwriting and stuff. I could have done better. But if you do have questions, let me know. I still did go through the problems with you. I went through the notes with you. You can pause the video as you go and see if any of that doesn't make sense with anything. Because again, this was one of the harder chapters. Those were pretty difficult problems. You do have a final, though. You do want to make sure you get this stuff and have it written down in your cheat sheet. And those were good examples. So I hope that worked. And off you go.